So hello and welcome again, Microbehunter here. Recently I took a trip to a nearby pond and collected some sediment and some sand from the bottom of the pond, and I brought it back to the lab, or rather to my apartment, to see what I could find under the microscope. And guess what? I stumbled upon a fascinating little discovery, a tiny microscopic mussel, a seashell or bivalve. And at first, I almost completely overlooked it because it was quite small, of course, and it also moved much more slowly than some of the other creatures that were in the sample. And I nearly, overlooked it because it was also very transparent. But once I spotted it, I realized that there is so much to learn from this tiny little mussel and from how it attaches itself to the surfaces, to the potential secrets hidden inside its shell. And now I'm going to be diving into the mysteries of this tiny bivalve. So one of the first things that I noticed is how this mussel's foot, that is this long flexible extension, is able to grip on the surface of the glass slide. Now it's interesting because glass is very, very smooth, and normally mussels use their foot to dig into the sediment and also to bury themselves. But here it seems like it's holding on just fine. And I kind of started wondering how this little guy is actually managing to attach itself and to pull along its comparatively heavy shell. So it's some kind of a suction mechanism, maybe. I'm not quite sure, or maybe something similar to how limpets. These are also mollusks that attach themselves very strongly to rocks. How limpets or snails maybe attach themselves to rocks. Well, I'm not entirely sure. In any case, it's a fascinating question. Maybe some of you know a little bit more about that, and you can maybe leave a comment behind. Because mussels are not really exactly known for gripping on to smooth surfaces, so it's definitively something that I'd be interested in knowing a little bit more about. And next up, let's talk about the rings that can be found on the shell. You might assume that these rings are only an indication of its size, but they can actually also serve as a record on the mussel's age, a little bit like the rings of a tree. Now, every year the mussel forms a new ring as it grows, and by counting them, we can estimate how old it is. But that's actually not all, because these rings also tell us something about the conditions of the mussel experienced throughout its life. So if the rings, for example, are spaced closely together, then this might actually mean that the mussel went through very tough conditions and it was not able to grow very quickly. So maybe there was a lack of nutrients, or maybe also colder water temperatures. And on the other hand, maybe wider rings might indicate maybe times of rapid growth and more favorable conditions. So it's a little bit like a history book that's built right into the shell. Now here's a question that I've been thinking about. Now, could these shells also contain more than just age and growth information? Could those shells maybe also have a record of the environmental conditions like pollution or temperature changes? Well, as the mussel grows, it might absorb tiny particles of pollution or experience shifts in water chemistry. And maybe they could leave traces behind in the shell, because something similar, after all, also happens to our hair. If certain substances are consumed, heavy metals, for example, then they will also be deposited in our own hair. So maybe something similar also happens inside the shell of a mussel. And if this is the case, then these microscopic mussels could act like environmental time capsules, which give us a glimpse into the past. Now imagine being able to analyze an old mussel shell and figure out what the water quality was like decades ago. Well, I think that would be a pretty exciting idea. I do not know very much whether these types of research are already conducted or not, but especially for studying the impact of pollution or climate change over time, it might be quite a fascinating little project. Now, aside from being potential environmental recorders, these tiny mussels play also a very important role in the freshwater ecosystems in general, because they're filter feeders, and which means that they help clean up the water by removing small particles and even in some cases even pollutants. A single mussel might not seem like very much, but when there are thousands or hundreds thousands of them together in a body of water, then this can make quite a big of a difference. Not only that, but they are also an important food source for other animals, and their presence often indicates that the water ecosystem is healthy. Some of these microscopic mussels are tough little survivors too, because they can endure poor conditions like low oxygen levels or even higher pollution, making them pretty resilient creatures. So what does this all tell us about our tiny little friend here under the microscope? It might be small and easy to miss, but there is so much more to it than meets the eye. So from how it attaches itself to smooth surfaces, to the clues that the shell might hold about the environment, this tiny mussel is full of fascinating mysteries, and I think we're just scratching the surface here. Well, let me know what you have, if you have any questions and what you think about this. Maybe you can also contribute some information here about these tiny creatures in the comment section below. I'm always excited to hear what you think, and as always, if you enjoyed this microscopic exploration with me, don't forget there is somewhere a like and a subscribe button around here. Yeah, for more discoveries of the world of the microbe-sized. That's all that I want to share with you today. I wish you all the best. Happy microbe hunting as always, and see you around in the next video. Bye bye.